Right, so again, my name's Andy, bit of a theme tonight. I'm going to talk about the cloud part. So Andy's covered very much that live virtual production element. I want to explain what Amazon is doing to make the cloud sustainable, what you can do, and why it's important. So there's a whole lot of stuff on there. Probably organizations are seeing pressure from inside and out, from your customers, from employees within the business who are actually starting to want to work for sustainable employers. The big part is the money element. If you are a large organization buying services, you want to buy from sustainable suppliers, and we're seeing this as part of procurement processes. If you're a partner and you want to sell to large organizations, this also is important for you as well. Practically every organization has some sustainability goals of some description. How many people know your sustainability targets? Oh my word, that is perhaps 1 in 10 maybe. So a bit of homework for you. Go and find out what your sustainability goals are for your organization. So when people come to talk about sustainability, very often the first part of this is to understand what your footprint is right now. You can't improve anything if you can't measure it and you don't have a baseline. When people come to us, they say, tell me want to know what's the footprint of my AWS usage. And we'll show you how you can answer that. About 30 seconds later, the next question is, how do I reduce it? Now that I know what it is, how do I make it less? And there's a whole lot of things that AWS is doing and that you can do that will actually reduce that. Once you get a bit further into that, how do I reduce it part, begin to realize that a lot of those things outside of cloud and outside of technology is where a lot of the carbon is. So if you want to reduce that, you can actually use some of the cloud technology to start to reduce it in the rest of your business. And also, as you begin to look out, you realize that it's not something you can do on your own. It becomes something working in collaboration with all of the partners that you work with. Now, the way that we think about this is with a shared responsibility model. There's one for security. This is the shared responsibility model for sustainability. So the bottom half, that's sustainability in the cloud. That's the part that AWS and Amazon are doing. The top half is the part that you can do. So in that bottom part, AWS's role is to make the cloud as sustainable as we can. And this covers the servers and storage and devices that you use, also the software and operations of those services that are part of it. It also covers all the things that connect them, and even things like power distribution inside the buildings, how we power those servers, how we cool them, even the energy involved in cooling them. It also comes down to things like the steel and concrete that the buildings themselves are made of. Steel and concrete, they actually involve a surprising amount of carbon in producing those. So there's big investments. AWS is invested into organizations that will help us reduce the amount of carbon involved in even producing the buildings that the servers live in. The other bit is what you can do in terms of architecture. Now, very often we think about the way that we use things like EC2 instances. Is it the right size instance? But actually, it's not just hardware. The way that you implement your applications, the way that you design and architect them, and the way that you host them makes a massive difference to the amount of resources that you need to do the same amount of work. That drives your energy consumption, and that in turn drives the carbon emissions at the end of it. And even if it was all 100% renewable, which will be soon, we still want to drive that energy efficiency part to make sure that you can do as much work as possible with the least amount of AWS resources. Now, one of the big parts is the renewable energy. Amazon is on a path to be powered by 100% renewable energy by 2025. That's actually earlier than the original target that we'd set, and that's the whole of Amazon. That's not just AWS, that's every part of Amazon. At the end of 2021, it was 85% renewable energy usage across the whole of Amazon. We also published a list of AWS regions that are using at least 95% renewable energy, and that covers a lot of the regions in Europe, also regions in US and Canada as well. These are all at least 95% renewable energy. So that gives you a lot of choices in terms of regions. When we think of those, we think of what are your business requirements and what are your sustainability requirements. You always want to make sure that you're meeting your business requirements, but we want to give you the options to make those sustainability choices as well. And we talked about some of the innovation inside the facilities. One of the most visible, few people get excited about UPSs. Like, there's a big change in UPS design that saved a lot of energy. Strangely, it's hard to get excited about for a lot of people. But the Graviton instances, Graviton 3 is like the third generation of AWS designed silicon. They're ARM-based processors. There's a lot of optimizations that have gone into those. And these are up to 60% less energy for the same performance as comparable instances. With Graviton 2, we said they were more performance, but we didn't really talk about the energy. This one, up to 60% more energy efficient for the same performance. And we keep coming back to that thing. It's how much work can you do and how little resources can you use to do it? Now, the big benefit here is that compared to running on-prem, I have to say the right words, according to reports from 451 Research, compared to the enterprise data centers that are surveyed, AWS was found to be, in the US, 3.6 times more energy efficient than the median of the data centers surveyed. In Europe, up to 5 times more energy efficient. Sometimes people don't believe this, because most people believe that their on-prem estates are much more heavily utilized than they are. But a large part of this comes from, some of it's renewable energy, some of it's from more modern processors than are running in some of the data centers. Within these reports, there's a fabulous table that describes generations of processors becoming more and more efficient. It also describes the load on them as well. So if you load processors more heavily, they actually become more efficient than when they're very lightly loaded. So if you've got idling servers, they're basically bad for the environment. But it's the utilization that drives a lot of the benefits here. In the cloud, where you've got large amount of customers, large amount of capacity that can be allocated differently, this allows us to run at much higher utilization than is possible in most of the on-prem data centers. The other thing is just the efficiency inside the data center. Cooling in places like Ireland for 95%, more than 95% of the year. We don't use any water. It's all, cooled using what's the word? We don't use any water for 95% of the year. So it means that we're using a lot less energy to actually cool the facilities as well. So we talked about carbon footprint. This is the AWS Customer Carbon Footprint tool, or it's a screenshot of one. How many people have got access to a billing console? Oh, that's a bit better. At least a third, maybe half, have got access to the billing console. Have you scrolled down to cost and usage reports and looked at your customer carbon footprint tool? Few nodding heads, few brave hands. So a few people have. This is in every AWS account. And it's free. You do need IAM permissions, but it's free. It's in every account. And it will show you the carbon emissions for that account. It will show you, I thought this would be on a bigger screen, to be honest, but this tiny green number here, this tiny green number, that is your emissions in metric tons of carbon dioxide equivalent. The number next to it, the blue one, that's estimated methodology from the 451 reports. Goes back to January 2020. You can see it month by month. So even if your reporting year varies a little bit, you can filter it out and you'll see the sort of progress that you're making across that. This is for scopes 1 and 2. We're working on scope 3 at the moment. So this will answer your first question. What's my usage? When people compiling your annual reports come and ask what's the usage, you've got a number right there that you can go and use that for reporting purposes. The next question that comes a few seconds later is, how do I make it less? And that's why we've added our 6th pillar to the well-architected framework. Everyone familiar with well-architected? Some nodding heads. Well-architected is best practice distilled into a paper. So it covers all of the areas that you usually associate with architecture, but you get a new set of trade-offs as well for sustainability. And this is about 15 months old. It had a big revamp between mid-December. So it's a bit more crisp, a bit more prescriptive. But at the core of it, it covers best practices in 6 different areas, 6 sets of patterns that you can use to look at your architectures in terms of sustainability. Some of them are really obvious, things like use the right hardware for the task and make sure that you're utilizing it effectively. I think most people find that the most intuitive. There are things like Trusted Advisor, even Compute Optimizer to help you go and find the right instances based on usage and based on metrics. Please make sure that you're doing that. It's all there. We find that a lot of people don't look at it, but it's there and it will help you find the most efficient instance types for your workloads. The one where we find least intuitive is within the software and architecture patterns, where we encourage people to look at SLAs. Now again, wow, SLAs, that's pretty exciting. But actually, we often find that people are scaling when they don't really need to. You get examples where you're either doing things faster than you need and spinning up resources that actually you don't really need to, or we get people within this user behavior thing. One of the things that we see in a lot of media customers is we see spikes. Sudden spikes, lots of resources. Even worse, you scale for peaked because you want to make sure that when the spike comes, you know that you're ready. But there are smart strategies to try and reduce those peaks. We also are really insistent that if your users are creating peaks, that's great. If you're creating themselves by running all your cron jobs at 3 in the morning, precisely, don't do that. That's a definite anti-pattern. And in terms of things like, we'll talk about data in a minute as well, but in the media examples particularly, I want to pick out some things where there are already use cases that you can go and look at and find that are in the public domain where people have talked about this already. So this one, I don't think we need to talk about that one anymore. I think you kind of know how that works. But there are other examples. Sky have done some work in that area as well. A firm called Media Monks, or maybe not quite so well known in the UK. They did a little talk for us at IBC as well, where they talked about how they've reduced the number of people that they're sending to sites to do the same thing. Within supply chain, I mean, supply chain's a vast area. There's a million things that can fit into this. There's a story from UK TV. Originally, they'd gone for a lift and shift approach, taking a MAM system and moving it to cloud. They've then looked at our serverless, event-based architecture, initially for cost, but actually they've discovered they're using far less compute resources, and it's delivered another benefit for them. There's also SDVI. They reckon that they've saved something like they can do 39% more work, or use 39% less compute to do the same amount of work. And in their case, that saved them something like 12,000 servers. And the last part is the edit in the cloud. We see some of our partners in particular have a lot of studies in this area, where again, it's things like using what you need when it's there. Like my mum told me when I was little, turn it off if you're not using it. But also, it's all the things outside of that. So how many people are you sending? Are you all of those physical world things as well, all contributes to carbon footprint. And actually using a little bit of technology in a smart way can reduce a lot of that carbon as well. And then I can't remember if I've animated this one or not, but let's hope we're okay. A lot of streaming platforms already run on AWS. These are really good candidates for optimization because you've got a lot of data, you've got a lot of user patterns that you can watch as well. And with things like containers and serverless, you get a lot of metrics and you've got a lot of scope for optimization, particularly if you've got control of the software. So within that software and architecture element, the languages that you've implemented your software in makes a massive difference compared to best to worst is something like a 75 times difference. So there's a lot of scope to optimize in there. Again, there's a lot of metrics, and you can, if you track those, you can start to drive improvement time after time. Within playout and linear, you've got all those benefits of renewable energy, efficient servers, so there's less than on-prem. Also, if you want to know how to schedule these for things like event-based systems, using things like step functions, my man there in the purple t-shirt has written a fantastic blog on optimizing things with step functions. So there's a lot that you can do in that area as well to automate that. And also, in terms of the data analytics space, practically every large organization is using masses of data to understand their customers, to understand behavior. It's generating a lot of, it's not traditional video workloads, but it's very much central to understanding whether you're doing the right things at the right time. There's masses of scope for optimization in these. In terms of data redundancy, in terms of how much data you process, where you store it, how long you keep it. And that's all described in the well-architected pillar. The last bit that I want to talk about is a little bit of terminology. I've said scopes a couple of times, scopes 1 and 2. I think I might have said scope 3 as well. Who's comfortable with scope 3? Who could tell me what it is if they were put on the spot? One person. Two, okay. So when you talk with your sustainability professionals inside your organization, they will talk about scopes and they'll assume you know, because it's something that's very much part of their world. Scope 1 is basically things that you burn, things like diesel fuel, heating oil for buildings, those sorts of things. Scope 2 is the emissions associated with electricity that you're consuming within your organization. And scope 3 is everything else, including everything that's done by partners on your behalf as part of supply chains, distribution chains. Which one do you think's the biggest? Yes. You can't hear, but honestly, people are telling me it's 3. I think that's what they're holding up anyway. Scope 3 is by far the biggest. For media companies, it's at least 90%, according to the annual reports that I've looked at. At least 90% of that is scope 3. And there are a lot of challenges in there that are all going to require lots of solutions. And it's not an overnight task, but it's something that's starting now. In terms of not just the number of trucks that you're sending, but also in terms of what you're buying, what services even that you're buying from your providers. All of that is part of that scope 3. And that's the way to tackle that is to understand, again, measure it, reduce it, put the solutions in place to track it, and actually make decisions based on how much carbon is being produced by your partners and by your scope 3 elements. And within that, for most organizations, that AWS usage will fit in there as well. So the last thing are some things I'd like you to do later. So first of all, if you haven't looked at your customer carbon footprint tool and you don't know what your goals are, go and find out what your organization's sustainability targets are. Go and have a look in the billing console and figure out what your emissions are right now. Second, the well-architected pillar is on the AWS website. If you search for AWS sustainability pillar, it will take you right there. You can read through the latest and greatest version. After you've read it, pick a workload and review it and see where you've got opportunities to optimize it and save yourself some energy and some carbon. And then the last part is to think about all of those elements that are part of that scope 3. What problems can we solve now? Where can we start to use some of the data, some of the technology to actually reduce some of your emissions in the rest of the world? And if you'd be so kind, we'll love a bit of feedback. So instead of bits of paper, you can have a go on the QR code if you like, but be nice. If you've got something, obviously, if you've got questions, I'm happy to have a few questions if we've got time, Paul.
Yeah. Yeah, why not?
We got questions.
We got questions.
Hi, Andy. Thanks for this lovely talk, first of all. I was wondering, you mentioned a few times that your goal, the AWS goal, is to be fully green and fully renewable by 25, I think, right?
100% operations powered by 100% renewable energy by 2025.
So my question is, could you describe the strategy, how AWS is actually procuring that renewable energy? I wouldn't imagine you building the turbines yourself, right? So is it something that you decided to do specifically with wind or specifically with sun, or you depending on the location? How do you do this?
So I know a few people in the team that work with the energy providers, and I've seen pictures of gigantic turbine blades and traffic lights being moved to get the turbine blades through. So yeah, it's working with long-term contracts with energy providers where we're looking to provide wind and solar. There's 160 utility scale wind and solar farms around the world. There are some in Ireland, there are some in Scotland. Solar projects in parts of the US, also with battery storage as well, which is quite exciting. So the first few battery storage projects are coming out as well. But that's the goal, is to build enough new capacity to power the business by 100% renewable energy.
It's only solar and wind. We don't talk like nuclear.
No. unless you know something I don't, there's no nuclear.
Is that referred to as the nuclear option? I'm going to take a page out of Tony's book and ask two questions. First one might be a silly question. Does it mean that in 2025 the kind of that sustainability dashboard will just have a big zero in it? What can we expect in 2026 to find out when we look in our billing section under sustainability?
It won't be completely zero until we've got rid of things like the... So Scope 3 is going to be a big part of it. Also things like within all of the data centers, obviously there are standby diesels in case we should ever lose power. We are looking at alternative fuels and alternative methods to power those. But right now, diesel fuel is probably the thing that's going to be in there. The goal across the whole of Amazon is to be net zero by 2040. It's 10 years ahead of the Paris Agreement, 10 years ahead of the UK target. But nonetheless, there are broadcasters and media organisations who are ahead of this even, who want to be even faster. They have the advantage of not having a gigantic online shop to deal with as well, and food stores and all that stuff. But yeah, that's what we're aiming for.
Yeah, and so I think that's the interesting part of it. It's almost scary when you think about Scope 3 in terms of a company trying to influence the staff to reduce their usage of how they commute into work and make that more sustainable. This is just a general question. Do you think that your Scope 3 as AWS needs to come under my kind of Scope 3 when I'm working out my sustainability for the company that I run?
I don't think the methodology has been defined yet, so we'll have to come back to that one.
That's a fair comment.
We all take care of our Scope 1 and 2s. The Scope 3s take care of themselves.
An anti-Ponzi scheme.
Who? Sorry. Oh, Dave. Dave.
I've been good.
You have.
So, Andy kind of hinted at something earlier, and I've heard it at other meetups here, issues around if you're good and you make sure you're not using instances when you don't need them, and then you're running a match and you need those instances. How do you deal with I need those instances and I need these sites because that's what the process needs? How do we deal with how do I get those and I only have one choice about what I use. And I've heard this around the place that you can get really screwed over by not running them all the time to keep them reserved.
Don't have to run them all the time. There are things like reserve capacity. There are, we like diversified fleets wherever you can. If there is like one particular instance type and the only thing that you can use is like a big multi-tenant environment, so there's going to be, what should we say? I mean, within those, it does happen. We sort of take the view that our CTO's motto is everything breaks all the time, and we try and design things that will cope when things break as well. If you're really dependent on one instance, that's always going to be a problem for anything in any scenario. There's always a risk inherent in that.
But shouldn't the pricing models reflect that a bit better?
You repeat the tape.
Pricing wise, that should be reflected better. Hypothetically, I've got a workload that I use 7 in the evening, 7 in the morning.
Mm-hmm.
BT can't use that during the day because I've reserved it, because that's the only way I can buy it. So there needs to be a bit of give on AWS side there, I think. We're being good, we're turning it off, but no one else can use it because we might need it.
It's good feedback.
That's hypothetical.
Can I add to that? As we've
No, you can't keep spot instances if you've got statics just.
yeah, they can shut those
We're
down.
not solutioning.
So one thing I'd add is when you're picking the tools for live production, first of all, if it can only run on the largest G4DN that you can buy, it's probably not the right tool. And I think there's a few people in this room that have been in a situation where G4DN X larges or 2X larges were the most common that everyone recommended. But I've never been in a situation where you scale upwards to a larger instance of with the graphics on it that I haven't been able to get it. Now, you could say you're wasting carbon by running it on a larger instance because that's what you could get, but you're turning it off for the rest of the week. So I think understanding your production workflow and how to get out of those holes is as important as just saying it wouldn't launch, because and also being geographically diverse, right? If you're running in London, you know you're going to be short of graphics instances from time to time.
Yeah.
So have a workflow where you can jump to Ireland if you need to, if you can.
True.
We face this. That's cloud native media right there.
And I would say, and it's business needs as well as sustainability goals. You've got to meet your business need because you need to stay in business, but also do it in the most sustainable way.
We
There you
face
go.
this same thing where we have customers running a single availability zone, hitting G4DN, 2XLs, 4XLs, that kind of thing. And it started to stem a negative behaviour where people were going 6 in the morning, 20 machines, so I don't want to have to take flak at 9 a.m., And part of that was that through kind of optimization, people have gone down the one availability zone route with it. And it was only once we got into that, we found out that the concept of hitting the stops in one availability zone and then stampeding to another, if you haven't run a specific instance type in another availability zone before in that VPC ID, you're bottom of the queue. So it kind of taught us actually, we need to go quite broad with it. We need to be 3 availability zone out the box, even if that means 3 VMs in 3 different availability zones, and there is some inter availability zone kind of egress charging with it. The payoff is that we get much higher assurity of instance when we need it, and that means we can then be much more aggressive in how we trim fat with it. So that was something that we learned through the pandemic. We started off with we don't want to pay egress, the edit instances, that kind of stuff. We'll just put it in AZ8. I know it's different for everybody, but then you just be like, so the second point that also people made is that same thing. We became completely dependent on G4DNs. We had to think, well, what if? Well, fine, we'll just spin up some instances that don't have GPUs or have a different GPU. It's not quite the same user experience, but it'll get us through the couple of hours that we need it to until the resources do come online. So having technology that doesn't just go, fire the API, it's failed. by the way. You know, going, okay, well, what do we do next? Right, well, we look at the other availability zones. Right, if they're out, what do we do next? Right, well, we look at instance families that don't have that, and we change the SLA, the user experience on that kind of technology.
Fantastic. I know there are more questions, but I also know what time it is. And it is getting a bit late. So, Andrew, are you coming to the pub?
I'll come over, yeah.
Yeah. So Andrew,
More
and I think
questions?
Andy's coming to the pub, and David's going to be in the pub. So if you've got more questions, please do come over to the 1 Ton with us. But I think it's about time to wrap up tonight at Cloud Native Media. So a big thank you to Andy Beale. And his Debbie McGee reborn there, and Andrew as well for a fantastic talk on sustainability. There is, I believe, there is a load of beer back there still to drink. So please do crack on with that. We don't want to be carrying it home, storing it. I mean, I've carried home beer from this thing more than once, and you know, I have to bring it. I just have to bring it back again next time. So just drink it, guys. We'll see you in the pub. We'll put the map up on the screen if you want to join us. But thank you very much for coming. Awesome. Very good.